Alright, so here is the review for the comparing and scaling unit test. Just a reminder that this test will be on Wednesday, December 2nd. Okay, so this is the list of what we covered from Investigation 1. I'm primarily going to focus on Investigations 2 and 3 in this video, but here are the topics we should make sure we know from Investigation 1. All right, and then here are the list of topics that we covered in Investigations 2 and 3, or sections. So just to make a note, we did skip section 3.2, so you don't have to worry about that. All right, so for Investigation 1, I do want to go over how to set up some proportions. So we need to remember to label everything, use a variable, and set up the proportions correctly. So in this one here, they tell us the ratio of boys to girls is 4 to 6. So we have 4 boys to 6 girls. Okay, and if there's 1,260 students total, we want to know how many girls there are, and we want to know how many boys there are. So if we were solving for how many girls there were, we would say, or I'm sorry, let's solve for how many boys there were. So 4 boys over 10 total students, and that would be equal to X boys over 1,260 total students. And we can see that we can either scale this by a factor of 126 to get that X equals 504 boys. Or we could have cross-multiplied if we wanted to. So to get girls, we can either take 1260 minus 504 to get 756 girls. Or we could set up another proportion. So the girl proportion would be 6 girls for every 10 total students equals X girls for every 1,260 total students. So we could multiply that by 126, or we could cross multiply. So either way, we get that the number of girls is 756. Okay? So moving on, for this one, we want the ratio of skiers to snowboarders. So skiers to snowboarders is 4, let's say SK for ski, and 7 SN for snowboarders. So they tell us that there's 40 skiers, and we want to figure out how many snowboarders there were. So instead of using a part to whole comparison like we did last time, we're going to use the parts. So 4 skiers to 7 snowboarders is what we are given. We want to find out how many snowboarders. So X snowboarders for 40 skiers. All right, and the reason that I put X on the bottom is because it matches up with this. So snowboarder here, snowboarder here. All right, so then when you solve that, you get that X equals 70 snowboarders. And you can see that we scale this by 10, so we can scale this by 10. We could also cross multiply if we want. Okay, so moving on, this one, everyone in the class got an A or a B, and we know that there are 7 A's for every 5 B's, and 84 tests total. So they want to know how many A's there were. So we know the total amount of tests. So therefore, we want to set it up 7A over 12 total of this one here. So if just one round, 12 total equals X number of A's if we have 84 total tests. And when we solve this, and again, we can scale or cross multiply. All right, so 84 divided by 12 is 7. So you would times by 7, multiply by 7 up here. So x equals 49, and we need to say a's, right? So that is the answer. Now, they don't ask you for b's, but if they did, we could just take 84 minus 39 to get 35 b's. Okay, so for proportion, just make sure you see what they're asking you and what they're giving you. So here, this is what we were given, and this is what they were asking us. Okay, so moving on to 2.1. So we know a bunch of different strategies for comparing rates, and we want to remember that rates are ratios that compare unlike quantities. So, for example, say there's a large table that seats 13 people and a small table that seats 11 people. All right, if there's 7 pizzas on the large table and 6 pizzas on the smaller table, where should you sit to get the most pizza? Well, we know that we can set up common denominators by making the amount of pizza constant, common numerators by making the amount of people constant. But we've also focused on this here, these rates. Right? So if I have 13, let's say, people for every 7 pizzas, if I divide both sides by 7, I get 1.857 people for every 1 pizza. All right, on the other hand, if we have 11 people for 6 pizzas, if you divide both sides by 6, get 1.83 repeating people who share 1 pizza. So here we want to pick the one that has a fewer amount of people. So in this case, the small table with 11 people will give you more pizza because 1.83 is smaller, or 1.83 repeating is smaller than 1.857. So we could have also found the opposite unit rates. So for the large table, if you divide both sides by 13, you get 1 person, 2.538 of a people, or pizza, and that's for the large. So for the small, you get 1 person for every 6 divided by 11, which is 0.54 repeating pizza. So here we want to pick where the amount of pizza per person is the largest, and again, we see that that is at the small table. All right, so you can solve these types of problems any way that you would like. We really focus on unit rates this unit. Okay, so moving on to more about unit rate. So 2.2, well, we know a rate is a comparison of 2 quantities measured in 2 different units. So some examples, 8 miles in 4 hours, 350 miles to 10 gallons, 10 bananas for $5, right? These are all different units. So unit rate is a comparison of 2 quantities, comparing one of the quantities to one. Most of the time we write that second quantity as the one quantity, okay? So, for example, if you have 8 miles to 4 hours, if we want 1 hour, we divide both sides of the ratio by 4 to get 2 miles for every 1 hour, or 2 miles per hour. All right, so on the other hand, We have 350 miles to 10 gallons. Well, if we want 1 gallon, you divide both sides by 10 and you get 35 miles per gallon. Okay, if you have 10 bananas for $5, if you want to know how many bananas $1 can get you, you divide both sides by 5 to get 2 bananas per every $1. But on the other hand, if you want to know how much 1 banana costs, you divide both sides by 10. So then you have $0.5 per banana. All right, and then just a note, this is also known as a unit price because 1 unit, so 1 banana, costs 50 cents. Okay, so to find unit rates, you divide one value by the other depending on which unit rate you want. So for example, if we want miles per hour, you divide miles by hour. All right, so moving on to more examples. So you can also use rate tables to find unit rates and other quantities. This is one of the examples from the homework. So if we take a look, Joel can drive his car 450 miles at a steady speed using 15 gallons of gas. And we want to make a rate table for 1 to 10 gallons of gas. So first we want to find the unit rates. So right here, we're given 450 miles for every 15 gallons. Well, if you divide both sides by 15 to get 1 gallon over here, and then 30 miles, it would be 30 miles per gallon. All right, so 30 mpgs. On the other hand, if we set it up like this, where we put 15 gallons to every 450 miles, divide both sides by 450, and we get 1 over 30, so 1/30th gallon for every 1 mile. Okay, so this would be like 1 over 30 gallons per mile. All right, and miles per gallon is the most popular unit rate over gallons per mile. So we don't really think of it typically like that. Okay, but you could also set up a proportion. So if you have 450 miles to 15 gallons, that is equal to X miles over 1 gallon. And you will get 30 miles per gallon. On the other hand, the other unit rate, it would be 450 miles to 15 gallons equals 1 mile to X gallons. Okay, and when you solve that, you will get 1/30th. So you could use this way or this way, either one to find the unit rate. Once you do, well, we know that 1 gallon is 30 miles, and it increases by 30 for each gallon. So then you can fill in the corresponding 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's this side here. All right. So if we wanted to make this an equation, we see that the miles depends on how many gallons you have. So if you have 1 gallon, you go 30 miles, 2 gallons, 60 miles. And we see that relationship there of miles equals 30 times gallons, right? So this is times 30, times 30, times 30, and so on all the way down. So every gallon multiplied by 30 gives you the amount of miles. So know that this is a good equation. If we wanted to go the other way, if we wanted to find an equation starting with G, well, we just see that all of these miles divided by 30 give you the corresponding gallons. Okay? So both of these are valid equations. You could pick them out of a rate table if you make one, or you can use the unit rate. So we found the unit rates of 30 and 1/30th, and to put them into an equation, you just need to figure out how they relate to each other. So 30 miles per gallon means that for every gallon you use, you get 30 miles of it from it, right? So that's this here. So miles equals 30 times G. All right, so moving on, once you have your equations in your unit rates, you can use them to answer questions. So how far could Joel drive on 5.7 gallons? Well, if miles equals 30 gallons, we can just plug that right into the equation. So he you can go this many miles equals 30 times G, which is 5.7 in this case, and you get 171 miles. So that's how far he could drive if he had 5.7 gallons of gas. Okay, so how many gallons does Joel need to drive 428 miles? Well, we can just plug that right into this equation here. So G, how many gallons does he need? Equals 1 over 30 times 428, which is M. And when you solve for that, you get 14.26 forever gallons. So if you're rounding this, 14.27. Okay, so we can use these equations to answer questions. We can also just use the unit rates. So how far can you go on 5.7 gallons? Well, he gets 30 miles per gallon. So if he has 5.7 gallons, it'd be 30 times 5.7. All right, to get 171, which is essentially the same thing we did in the equation. All right, and then the same would go for this one here. So finally, we could set up a proportion. So if you know that he goes 30 miles in 1 gallon, he'll go X miles in 5.7 gallons. Likely, or also if you know he goes 30 miles for 1 gallon in 428 miles, he will go, or he will need X gallons, okay? So you can use equations, unit rates, proportions. We can also scale our rate table. So we have all these different strategies for solving problems like this. All right, so moving on to 2.3, unit rates and the constant of proportionality. So unit rate is a rate in which one of the quantities is 1. So, all right. So the constant of proportionality is the constant that you multiply one variable by to get to the value of the other variable. Or to get to the other, the value of the other variable. There we go. Okay, so what were the unit rates for Joule? Well, we know they were 30 miles per gallon and 1/30th of a gallon per 1 mile. And what were the equations? M equals 30G and G equals 1 divided by 30 times M. So these are the unit rates here. And these are the equations, and we know that these here are the constant of proportionalities, right? So since these are the same, and we have talked about these before, the constant of proportionality is also your unit rate. So in this case, the constant of proportionality is a unit rate of 30 miles per gallon. And in this case, the constant of proportionality is a unit rate of 1/30th gallon per mile. So again, remember the constant of proportionality tells you the unit rate, and the constant of proportionality is the constant that you multiply one variable by to get to the value of the other variable. All right, so how can you recognize a proportional relationship from a graph or a table? Well, if you're looking at a table, you have to be able to scale it by the same thing for every value. So we know that this one is always scalable. So if we went from here to here, 30 to 60 times 2, well, this is also times 2, right? This is times 3. This is also times 3. And that comes from the fact that you always multiply gallons by 30 to get to miles, and that you always multiply miles by 1 over 30 to get to gallons, okay? So if it was on a table, or sorry, if it was on a graph, There's a couple things we can use to recognize that it's a proportional relationship. But first, what would we do if we were asked to graph it? So if we were asked to graph this or graph a sketch of it, the first thing I would do is plot 0, 0, because we know that a proportional relationship has to go through 0, 0. Okay, the next thing I would do is plot the unit rates. So if you plug in 1 for x, the corresponding y is the other unit rate. And if you plug in 1 for y, the corresponding x is the unit rate. Okay, so we know that if there is 1 gallon, you go 30 miles. So this here, this 130 is a unit rate, and it's on the line. Okay. The other one would be 1 mile to 1/30th of a gallon. So if this is gallons, maybe that would be 1/30th. Maybe that would be 1 mile. That one's a little bit more difficult because of the scale, but this is the other unit rate. So we have 1. Okay, so x is 1/30th and y is 1. And then, so if we want to connect these 2 points, or 3 points, and that's our line. So it goes through the origin, through the 2 unit rates, and onward. Okay, so if this was an exact line, all the points should match up. So let's look at 5 gallons should be 150. That's about right. Okay, 10 gallons should be 300. A little bit off. So if this was a perfect graph, all these points would line up. So if you were given a graph or asked to sketch a graph, if you're given a graph, you know it's a proportional relationship. If it is a straight line and goes through the 0, 0, and you know that the proportional relationship matches your equation if you can pick out the 2 unit rates from these. Okay. Now on the other hand, if you're asked to sketch a graph, you can plot the 2 unit rates, plot 0, 0, and draw a line. If you wanted to add one more of these points to help draw your line, you could do that as well. But the most important points are the unit rates, so 1 comma y and x comma 1 and 0, 0. Okay, so moving on to 2.3. 2.3. So we talked about unit prices. So what is the unit price? So it's how much one of something costs. So if we wanted to find a better deal here, we would want to find out how much one pencil costs for each scenario. So if you divide both sides of this one by 14, you get 1 pencil. And 3 divided by 14 is 21 cents. Okay, so 1 pencil here costs 21 cents, and we got that by dividing by 14. All right, I just switched the dollars to the left-hand side. All right, so for this one here, again, we want 1 pencil, so we divide both sides by 20. So 20 pencils for $5. That would give us 25 cents because we have 5 divided by 20 for 1 pencil. All right, and the last one, 100 pencils for $15. We divide both sides by 100. So the right side of the ratio is again 1 pencil. And 15 divided by 100 is 15 cents, okay? So we just found the unit prices for all these 3 quantities, and we want to pick the cheaper one for the better buy. So 100 pencils for $15 would be the better deal. All right, so again, just to reiterate, unit price, how much one of something costs. So 1 pencil in this case. All right, moving on to 3.1. So here, I just listed the vocabulary. So we know the buying price is the cost for a store to buy an item. The selling price is the price the store sets for customers. The markup is the difference between the buying price and the selling price, and the commission is typically a percentage of the sale price of an item, and it's the money earned by the employee for the sale. Okay, so if we were given that the buying price is $1,500, how much would a 30% markup be? Well, we want to find 30% of $1,500, so we have $1,500 times 0.3, and we get $450. Okay, so what is the selling price? Well, the selling price is the buying price. The selling price is the buying price plus the markup. So that's $1,500 plus $450 to give us $1,950. Okay, so two ways to find the commission. The commission is 15% of the markup. So if the markup is $450 and we want 15% of that, we multiply 450 by 0.15 to get a commission of $67.5. Okay, so the other thing we talked about was finding the markup as a percentage of the buying price instead of the commission. So if a commission is 15% of the markup, so we want 15% of the markup. But the markup is 30% of the buying price. So we'll say 30% of B. So what we want is 15% of 30% of B. So on your calculator, you would find 15% of 30% by multiplying 0.15 times 0.3. And when you do that, you get 0.045, which we know is 4.5%. So the commission in terms of the buying price is 4.5% of the buying price. So finally, we find 4.5% of $1,500. So that's $1,500 times 4.5%, which is 0.045 on the calculator. And we get, again, 67.5. Okay? So when you're doing problems like this, remember that 15% of 30, you would find that by 0.15 times 0.3 on the calculator, and 0.045, right? That's 4.5%. So make sure we're entering percents correctly. All right, so we can do problems with proportions and percents. So if you know that the selling price is $5,000, which is 30% more than the buying price, what is the buying price? Well, 100 over 130% equals X over 5,000. And this is in dollars. Okay, so the reason why you can set it up this way is because $5,000 is 130% more than, or 30% more than X, which is the buying price. So if X is 100% of the buying price, where X equals the buying price, well then $5,000 is 130% of the buying price, because it's all the buying price, which is 100%, plus the markup, which is 30% more. All right, so we can solve that, and X equals around 3,846.15. And if you're concerned that you didn't get the answer right, all you have to do is multiply this by 130%, or 1.3, and you will get $5,000, roughly, with the rounding. All right. One other way we can set it up is we can say, well, $5,000 is 130% of the buying price, where X is 1,000 or 100% of the buying price. Okay. So you could also set the proportion up this way, and when you solve, you get the same answer. Okay, this one here, the buying price of a car is $20,000 and the selling price is $25,699. So they are asking you what is a percent markup. Well, we can find the markup just by subtracting the buying price from the selling price. So the markup is $5,699. So what we want to know is what percentage is 500 or 5,699 out of 2,000. So two ways we can solve this problem. So x over 100%. So this is some percentage out of x or out of 100 equals 5,699 out of 20,000, right? So some percentage of 100 equals this, and it'll tell us what percent 5,699 is out of $20,000. All right, so when you solve for this, you get approximately 28.5%. Okay, so we could also just divide 5,699 over 20,000, right? So that tells you what percent 5,699 is of $20,000. It just gives it to you in decimal form. So you're just missing this times 100 step over here. So this would give you like 0.285 on the calculator, which we know is 28.5%. Okay, so now this is the restaurant example. We talked about this a few times. So if you and your friends go out to eat and you have $75 to spend, so this is the total amount that you can spend. So you want to find the maximum amount of food you can buy, so just food, right? So you let tax here be 7% and you want to leave a 20% tip. So if $75 is the maximum amount of money that you can possibly spend, you need to include the price of food, tax, and tip. So if we let X be the amount of just food, 75 would be 120% of X because it's all the food, 100%, all the tax, 7%, and all the tip, 20%. And you can let that equal to X, the cost of food, over 100% of the cost of food. Okay? Or we can set it up with just percentages on the left side. So we know something's going to be 100%, something's going to be 127%. Let X equal the cost of food. So X represents 100% of the cost of food only, whereas $75 equals 127% because it's the cost of the food, the tax, and the tip. Okay, and when you solve this, you get X is about $59.06, okay? A couple ways that you can check this answer. You can plug it back into your proportions and see if it's equal. You can multiply 59.06 times 1.07. So if you take 59.06, multiplying it by 1.27 is saying what is 127% of 59.06. And when you do that, you get, it ends up being 75.0062 because of rounding, so it's about $75. Okay, so we know we did that right. You can also take $59.06, calculate the tax and the tip, and add that all together, and you'll get around $75. So the big thing here when you're doing these is make sure everything works in your proportion. Okay, another example of a proportion with a percent. So if a woman making $15 an hour gets a 22% raise, how much will she make now? So if we let X be how much she'll make after the raise. So if X is how much she makes after the raise, that's 122% more of what she's making now, which is $15 now, right? So what she's making now, $15. She's making 100% of what she's making now. X is the price of what she'll make with a raise. So she's getting a 22% raise. She's making 122% of what she's making now. Okay? We can also do just percents on the left. So 100% to 122%. And we just need to figure out what goes with 100% and what corresponds to 122%. Well, we know that 122% has to be the what she makes with the raise. So we don't know that, so it's going to be X. What we do know is how much she makes without the raise, $15, okay? And when you solve both of these, you get that X equals 18.3. So 18.3 is how much money she'll make after a 22% raise. All right, so moving on to 3.3. Recall that ratios can also be given to you in percentage form. So this is the problem that we worked with feeding the chimps, where it was ratios given in percents. So an example, let's say you took Ming's job and you're mixing food for chimps at the zoo. A new recipe required by baby chimps is 30% fiber and 70% protein. So we want to find the 2 unit rates. Okay? So the way that we solve this in class is making a rate table. So if we let this be scoops fiber, let's have scoops protein and total scoops, okay? So let me change colors. Okay, so say that you had 100 total scoops. Well, since it's 70% protein, that would be 70, and 30% fiber, that would be 30. All right. Now, what if we want to find the unit rate for just 1 scoop of protein? Well, we see that we would have to divide 70 by 70 to get the 1, so we divide 30 by 70, which reduces on to 3/7, right? So here we divide by 70 or multiply by 1 over 70. Okay, and then the total is 1 plus 3/7, which gives you 1 and 3/7 total scoops. Okay, now if you want to find the unit rate where the number of fiber scoops was 1, we could scale this. So how do you get from 30 to 1? You multiply by 1 over 30. So if you multiply 70 by 1 over 30, it reduces to 7 over 3. Total scoops, you add that up, 1 plus 7 over 3 gives you 3 1/3. Okay? So now we know from this our unit rates. So we have 3/7 fiber for every 1 protein, and we have 7/3 protein for every 1 fiber. All right, and that comes from this here. So that corresponds to this one, and this one corresponds to this one. Okay? You also could have just divided 3 by 70 to get, or 30 by 70 you get 3/7 fiber and 1 protein, and 70 by 3 to get 7/3 protein and 1 fiber. A rate table just might help you organize your thoughts. Okay? So what if we wanted to make equations for these? Well, let's rewrite our unit rate. So we have 3/7 fiber for every 1 protein, and we have 7/3 protein for every 1 fiber. Okay, so how do we make an equation out of that? So let's start with P equals. So how do you get protein given the amount of fiber? Well, we can look at our unit rates, or we can look at our rate table, and we see that when you multiply fiber by 7/3, you get the amount of protein. So we know that protein equals 7/3 fiber. Okay? And that comes from this unit right here. Because for every 1 scoop of fiber, we will have 7/3 scoop of protein. All right, on the other hand, from this unit right here, we get the equation F equals 3/7 P. And if we're unsure, plug 1 in for P. So if there's 1 scoop of protein, 1 times 3/7 will be 3/7. So 1 scoop of protein should give us 3/7 fiber. Let's check our rate table. 1 scoop of protein, 3/7 fiber, so we're good. All right, so if you come up with formulas like this and you have a rate table, make sure you check to see that you set them up correctly. Make sure it matches with your unit rates. All right, so once you have formulas, you can solve some problems. So if you use 20 scoops of fiber, how many scoops of protein do we need? Well, we know that protein equals 7/3 times fiber, where fiber equals 20, so we get 7/3 times 20, which is 46.6 repeating scoops of protein. So they would round that to 46 2/3 scoops of protein. Okay? So we could also set up a proportion. So if you didn't want to use the formula, or if you couldn't, or you weren't sure of yours, we know the rate of 30 fiber over 70 protein, right? It's in percents, but that's what was given to us in the problem. So if those are percentages, we made it 30 for every 30 fiber for 70 protein, because assume there's 100 scoops. All right, so 30 over 70, which also reduces to our rate of 3 fiber to 7 protein. So now we want to set that up for 20 fiber over X amount of protein. All right, so if you set up that ratio and solve for X, you also get 46.6 repeating scoops of protein. All right, so this one at the bottom, if you use 190 scoops total, how many of each will you need? Well, we know that we have 70 protein out of 100 total scoops, because 70% of 100 is 70. All right, so how many protein would we have then over 190 total scoops? Okay, so again, we're given 70 protein to 100 total scoops equals X protein over 190 total scoops. And when you solve that, you get 100 and X equals 133 protein. All right? Or we could set it up so that gives you protein. Now we could subtract 190, 133, 190 minus 133 to get 57 fiber, or we could show the other proportion. So just to show it, we're given 30 fiber over 100 total scoops equals X fiber over 190 total scoops. And when you solve that, you get X equals 57 fiber. Okay? So make sure you set it up with what they want. So here they want total. So if you're given percentages, you can figure out the total from 100. So if you have 100 scoops, 70% is 70, 30% is 30. All right, so let's say that you start with 50 scoops of protein and 50 scoops of fiber. So 50 protein and 50 fiber, that is what we start with. So how do we make this suitable for the chimps? So first we need to figure out what we have to add and how much of it. Well, we need the ratio to be 30% fiber and 70% protein. So 30% fiber, 70% protein. So we need more protein. So that means that we're going to be keeping fiber the same and figuring out how much protein we need to add. So if we're keeping fiber the same and changing protein, we're going to have X protein over 50 fiber. And we need to make that in a ratio of 70% to 30%, or 70 scoops to 30 scoops, or 7 protein over 3 fiber. Okay, and when you solve for X here, you get that you need 116.6 repeating scoops of protein total. So how many more do you need? Well, you subtract 50 and you need 66.6 repeating, or 66 2/3 more scoops of protein. All right, so take a look at with what you're given, figure out which one you need to change and which one is staying the same. So here we're changing protein and fiber staying the same. So then set that up to equal a ratio you know has to be true and solve. All right, so that was all I wanted to go over. If you have any questions, shoot me an email. And good luck.